Hello everyone, section 5.2, congruent polygons. Example 1, write the congruence statement for the triangles, identify all the pairs of congruent corresponding parts. So a congruent statement is something like triangle something 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 is congruent to triangle something something something, or polygon something something something. So the order of the first triangle or polygon is not important. I could call this M and P, I could call it P and M. That order is not important. The order of the second one, though, is locked in. What do I mean by that? Well, we have triangle M, N, P here. Angle M, or point M, matches up with which point in triangle over here? Well, M's got two arcs on it, Y's got two arcs on it, so M has to match up with angle Y. So let me write that down actually. Angle M is congruent to angle Y, since we're also going to be listing all the pairs of congruent corresponding parts. That's one pair of congruent corresponding parts. And since angle M comes first here, angle Y has to come first here. Let's go clockwise, not that it matters. I could go counterclockwise, clockwise. I'm going to go clockwise. So M, N, angle N, congruent to angle N, which has three arcs on it, matches up with angle X, which also has three arcs on it. N comes second, X must come second. Okay? And that leaves me angle P, congruent to angle Z. P comes third, Z comes third. Now, we also have to do the sides. Now, I can do them from the picture, but I can actually also do them from the congruent statement. MN is a side, they come first and second. YX must be a side, they come first and second. So MN segment is congruent to XY or YX. Notice one tick mark, one tick mark. They match up, they can correspond to each other. NP is congruent to XZ, second and third, second and third. And last, MP or PM has to be congruent to YZ or ZY. Three tick marks, three tick marks. And that's the answer to example 1. Example 2. In the diagram, we have this congruent statement. DEFG is congruent to QMNP. Notice the order of the letters. D must match up with Q, E must match up with M, so on and so forth. Find the value of X. So I could start with this one, but I'm actually going to start with this one because this one only has one variable in it. Segment MQ, first two letters here, must match up with segment ED over here. So I know you might think X minus 2 is equal to 12, but MQ does not match up with FG. MQ matches up with DE, so X minus 2 equals 8, X equals 10. Find the value of Y. Well, if X is 10, then this is 30 plus 2Y, and this is angle P. Angle P matches up with angle G. Angle G is 84 degrees. So 3x plus 2y equals 84. 30 plus 2y equals 84. 2y equals 54. Y is equal to 27. And there's the second answer to example 2. All right. Example 3, show that triangle ABC is congruent to triangle CDB and explain your reasoning. So there's a couple different ways of solving this problem. To prove two triangles are congruent, you have to show 6 things. You have to show 3 pairs of congruent sides and 3 pairs of congruent angles. That's 6 pairs of congruent corresponding parts. So I need to show that side AB is congruent to side CD. So this is missing in the diagram. I got this diagram from Big Ideas Math, and it was missing the A already. AB has to be congruent to CD, AB congruent to CD, and then that's part of the given information. BD is congruent to BD. Oh, that's right here. How do I know those two are congruent? BD is congruent to BD. Reflexive property. That was easy. And then last we have AD congruent to CB. AD congruent to CB, that's given information. Okay, so I already have my 3 pairs of congruent sides. I now need my 3 pairs of congruent angles. Angle A congruent to angle C. Angle A congruent to angle C. 1 tick mark, 1 tick mark. Congruent, given information. Angle ABD congruent to angle CDB. ABD, 2 arcs. CDB, 2 arcs. They're already given as congruent. We need one more pair of angles, and that's angle ADB right here. And we need to show that that's congruent to angle CBD right here. Now there's 2 different ways that we can do this. We can do this using the given information that we have parallel lines here, and that these 2 angles form the Z-like shape, making them alt-int angles. So they are congruent. 1, 2, 3 tick marks. 1, 2, 3 tick marks. So angle ADB congruent to angle CBD by alt-int angles theorem, or by the third angles theorem. I have 2 of the 3 angles of 2 triangles congruent to each other, so the third pair of angles must be congruent. So, or by the third angles there. Either one gets us our third pair of congruent angles, making these 2 triangles congruent to each other. That's example 3. Example 4. Find the measure of angle P. So I have 2 angles congruent to each other in 2 triangles by the third angles theorem. Angle A is 52, angle R is 52. Angle B and angle P must be congruent to each other. Angle B is 38 degrees. 180 minus 90 minus 52 is 38, making angle P 38 degrees. The measure of angle P equals 38 degrees. Example 5. Use the information in the figure to prove the triangle WXY is congruent to triangle ZVY. So again, we need to show 3 pairs of congruent sides, 3 pairs of congruent angles. Coming up, once we get to sections 5.3, 5.5, and 5.6, which are all grouped together, we will learn some shortcuts for proving triangles congruent, but until such time, you need to show 3 pairs of congruent sides, 3 pairs of congruent angles. We already have our 3 pairs of congruent sides given to us. So WX is congruent to VZ, XY is congruent to VY, and WY is congruent to ZY. So we have 3 pairs of congruent sides. We now need 3 pairs of congruent angles. Angle X is a right angle. Angle V is a right angle. Angle X, and that's what's given to us. They're not given as congruent. Angle X is congruent to angle V. How do we know that? By right angles theorem. Right angles congruence theorem says all right angles are congruent. So these 2 angles are given to us as right angles, so they must be congruent. What else do we have? Well, these 2 angles are congruent by VAT, vertical angles theorem. Angle WYX congruent to angle ZYV by vertical angles theorem, which leaves us angle W and angle Z must be congruent by the third angles theorem. Angle W congruent to angle Z by third angles theorem, TAT. Okay, if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. That's theorem 5.4, or the third angles theorem. We're going to use a little bit of algebra and the triangle angle theorem, congruence theorem, to prove that this must be so. It says explain. I'm going to actually, and then the answer key, it's just a couple sentences that explain why it must be so. I'm going to do a proof. So, to do the proof, I'm going to need 2 triangles, A, B, C, and another triangle over here, X, Y, Z. And we need some given information. We need to know that angle A is congruent to angle X, angle B is congruent to angle Y. And our goal is to show that angle C is congruent to angle Z. So, statement reasons. Statement 1, I can do, because I have a college degree, is put squigglies to rewrite the given information. You can't do that. You must rewrite the given information. Statement 2. These are triangles. What do we know about triangles? Well, we know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And the measure of angle X plus the measure of angle Y plus the measure of angle Z also equals 180. How do we know that? We know that by the triangle angle angle, I want to say sum theorem because that's what my previous textbook called it. Our textbook just calls it triangle angle theorem, which I just realized now I cannot call third angle theorem TAT because it's third angles theorem and triangle angle theorem have the same initials, so third angle theorem. No abbreviation for those two. Alright, statement 3, measure of angle A plus the measure of angle B plus the measure of angle C equals measure of angle X plus the measure of angle Y plus the measure of angle Z. What did I do there? Substitution. Property. Okay, well, stated up here in statement 1, which you've written out, is that angle A is congruent to angle X and angle B is congruent to angle Y. So if angle A is congruent to angle X and angle B is congruent to angle Y, I can subtract A and B from the left side, and subtract x and y from the right side, and I'm subtracting equal things from both sides of an equal sign, keeping the equation balanced, I'm left with the measure of angle C equals the measure of angle Z by subtraction property. Which leaves me just one final statement. Angle C congruent to angle Z. Definition of congruent angles. And what do we put at the end of all proofs? Q, E, D. My goal was to prove that the third angles, angle C and angle Z, must be congruent to each other with a little bit of algebra and some logic. That was example 6. Example 7 are some always, sometimes, and never statements. Fill in the blanks with always, sometimes, and never. An acute angle, an acute triangle is always, sometimes, and never congruent to an obtuse triangle. Well, if all three pairs of corresponding angles must be congruent, and if all three angles in an acute triangle are acute, and one angle, not at least, if exactly one angle in an obtuse triangle is obtuse, then they are never congruent. A polygon is always, sometimes, or never congruent to itself. Well, would a polygon's angles be corresponding to each other? Yes. Would they be congruent to those corresponding angles and sides? Absolutely. The answer is always. A right triangle is always, sometimes, or never congruent to another right triangle. Well, there are many different types of right triangles, and just because they have right angles in common doesn't mean that the other two angles must be congruent to each other. So this is sometimes. If triangle ABC is congruent to triangle XYZ, then angle A is always, sometimes, or never congruent to angle Y. Well, it's always congruent to angle X. It is sometimes congruent to angle Y. If the triangle is an isosceles triangle. If triangle ABC is congruent to triangle XYZ, angle B is always, sometimes, or never congruent to angle Y. Angle B and angle Y correspond to each other. They must be congruent to each other. This is always. Triangle ABC is congruent to triangle XYZ. Segment side AB is always, sometimes, or never congruent to segment side YZ. And the answer here, it is always congruent to XY. It is sometimes congruent to YZ. If the triangle is isosceles and AB is congruent to BC, then XY will be congruent to YZ and AB will be congruent to YZ. Okay, example 8. We're going to plot the given points. We're going to draw a triangle ABC, a triangle DEF. We're going to copy and complete the statement. Triangle ABC is congruent to which triangle? So it might be DEF, but that doesn't guarantee that D corresponds to A, or at least I don't know that they correspond yet. We're going to have to take a look. They might correspond to each other. That's what we're going to graph and figure out. So let's plot A is at 1, 1. B is at 8, 1. C is at 4, 3. There's point C. And here's triangle ABC. Okay, point D is at 3, negative 7. 3, negative 7. Here's point D. Point E is at 5, negative 3. Here's point E. And point F is at 3, 0. So now we need to determine, off the screen a little bit here. That's better. Now we need to determine what vertice A matches up with, whether it's F, E, or D, what vertice B matches up with, whether it's F, E, or D, and what vertice C matches up with. So notice AC is not the same length as CB, so that's going to help us to determine. AB seems to match up with FD, so that's a start. So let me write down here, triangle A, B, C, congruent 2. Now, so A is either going to match up with F or with D, and B will match up with F or with D. We don't know which yet. I do know that C matches up with E. As I look at this diagram, C matches up with E. So C is going to be last, E is going to be last in my congruence statement. They have to match up. So if I rotate, and this is why we did chapter 4, just prior to chapter 5, this is a rotation. Point D comes up here, point F comes over here, point E matches up here. If we rotate this, I'm not sure where the center of rotation is, somewhere over here. But to move from F to E, I go down 3, up 2. To move from A to C, I move over 3, up 2. To move from B to C, it's over 4, up 2. To move from D to E, it's over 4. It's up 4, over to the right 2. So A matches up with F, and B matches up with D. So triangle ABC is congruent to triangle FDE. All right, that was example 8. Finally, example 9. Again, we're plotting the given points, draw triangle ABC and segment DE. Then we want to find two locations of point F so that triangle ABC will be congruent to triangle DEF, again, so that they match up. Okay, that AB is going to be the same length as DE. But then I've got to make certain that point F is in a location so that it will make triangle DEF, not triangle DFE or something like that, that will be congruent to triangle ABC. So let's start off by plotting points A, B, and C. So point A is at -1, 0. Point B is at -5, 4. And point C is at -6, 1. Point C. There's triangle ABC. Point D is at 1, 0. Oops. And point E is at 5, 4. Here's D, here's E. And we've already got this set up so that it looks like a reflection in the y-axis. Point B has been reflected over the y-axis to point E. Point A has been reflected over the y-axis to point D. So one location for point F, which is the image of point C, is going to be a simple reflection. Okay, so if I move C over the y-axis, it ends up at here. We'll call this F1 because there's more than one location for point F. Making this simple triangle here. So that would make F1 have coordinates 6, 1. Now, that's not the only location for point F, and some people might think that I could put point F here. I'm intentionally going to get this wrong. Okay. So this is an incorrect location for point F, because triangle DEF in this location would not match up with triangle ABC. Triangle ABC would match up with triangle D. A to E, sorry, D to E, E to F, and then F back to D again. Looks like that one might actually work. F2. So F2 is at 4, -1. F3 would be over here. An image of F1. So now I have triangle DEF back to D again. Oops. And that one is at 2, 5. And D is the third side. It's going to be congruent to AC. I knew I was right the first time. So, point 2 does not work. I was right the first time because F to D has to be the same length as A to C. F to D is not the same length as A to C. So if I put point F in this location, this would be the same as triangle ABC would be the same as triangle DE would not be the same as triangle DEF, because FD wouldn't match up with AC. It would have to be D to F to E would be the same as A it would be the same, sorry, it would be E to F to D, and they just don't match up. And it was right the first time when I said that F2 wasn't correct and I was putting it in the wrong spot. And it's the same thing as if I did the image of F2 over here. Put it here. F4 also doesn't work for the same reasons. They just don't match up. So these are the only two that do work. Thank you very much.